Hey guys, so today I'm going to go through why LLMs hallucinate. And what I mean by LLMs is large language models. So stuff like ChatGPT or Gemini by Google or Anthropic's Claude. So these are like large language models. They kind of like form the foundation of a lot of the AI stuff you hear about nowadays. It's like generative AI. And I feel like if you know like the basics of this, it'll really help you understand stuff around AI, and it's actually going to be a benefit when you're actually needing to implement this into your business or life or whatever. So I'm going to explain it as simply as possible because I'm not a technical person. That's why I'm kind of like trying to make this as simple as possible for like business owners or just general everyday people or students or whatever. So let's get into it. So if you want a simple answer, why LLMs hallucinate is that they guess. It's kind of like a guess. And why that happens is, so basically how LLM memory works is, as many people know, training. These large language models are like using a lot of training data, like millions of books, the whole internet. They're always going through all this data, like millions of people's like feeds on Facebook or Reddit or whatever. Like so much data is going into them, and the more they keep needing more and more of this data to actually feed their algorithm, to actually improve these models, and therefore like decrease the chances of hallucination and so on. So I'm going to give you an example of how that works. Like technically, at least these particular models don't actually know the answer. It's based on patterns. So the patterns of their training data and how that training data was used. So I'm going to give an example. So when someone says, "What's the capital of France?" It's a pretty simple prompt that you might prompt into ChatGPT. The next word in the training data is often Paris, which obviously is right. So that's basically how an LLM works. And for something like this is an easy prompt. It's seen this in their training data because it's gone through like so much all over the internet and everything. This is an easy one. So it's very rare that they'd actually hallucinate in that. It's more when you get into more complications. So it actually doesn't, the LLMs don't actually know factually that Paris is the actual capital of France. They don't know like for 100% positivity that it is. It's just they statistically feel the likelihood of it being Paris is high. So it's statistical memory that this is based on, not actual factual. Because it's seen this, statistically this word comes after this type of prompt. It doesn't even have to be this exact prompt, but this type of prompt so much that it actually says, well, this is likely the answer, so I'm going to give the answer. But as I said, it's not always as simple as a prompt as this, and that's why it hallucinates. So if it hasn't seen this information enough, or it's new, it oftentimes guesses wrong. So if it's asked a question that is pretty rare, or there's not like a lot of information that's been trained on, or it hasn't really seen that information enough, like, and I'm talking about like it needs to be seen like almost millions of times to decrease the chance of hallucination. If it usually guesses it wrong or hallucinates, which is basically makes up answers. It's just like if you're putting in information into the ChatGPT and it gives you information and you just kind of know that's wrong. Like it's like the ChatGPT or whatever the LLM is, they don't actually tell you, oh, I'm not sure of that answer or whatever. They actually give you the wrong information. Now they're trying to obviously cut down on these hallucinations, but these happen because there's so much training data they need to get. They need to increase the amount of training data. So it's kind of like these more like, not even edge cases, but these cases that these particular prompts don't come up as much, that it kind of gets the answer wrong. And how we can actually use this, so you can actually create your own ChatGPT, which is like a mini knowledge base for you personally or for your business or whatever. So that's why we can actually use these foundational models, but on our own training data, and actually improve the answer. So it gives us the correct answer for our particular use case, because we provided with the knowledge that we need it trained on. So that's why you can use it in your business, or for a student, you can maybe put textbooks into this so you can kind of get the answer. It'll help your learning, help improve memory. And this is like basically these LLMs basically form the underlying effort of like all the new types of automation you can do for business or whatever. So I think this is very valuable. So let's get into that's like why we use RAG, and I'm going to explain exactly what RAG is now in a moment. But when we use RAG, it basically improves the chances of us getting the right answer on our own training, on the information that we provide the LLMs. So I'm going to kind of go into like some of the simpler basic things of LLMs and like creating your own training data. So stuff like what is a token, what are credits, or a little bit more complex, but what are vectors? So you can kind of get like just a general but simplistic overview of all this kind of stuff. So I'll just put that up on the board and let's get started on that. Okay, so what is RAG? RAG or RAG stands for Retrieval-Augmented Generation. Now that's a little bit technical, like what does it actually mean? Well, that means before AI gives you the answer, it actually goes and looks up the answer from your knowledge base and then presents that answer back to you. Now that's different from the overall like LLMs where like you go into like the ChatGPT interface and you ask it a question. That's based, as we discussed, is based on statistical significance, but not actual on the knowledge that you want it to present. So you might, for example, like in your business or your life, you might have like actual information, like context about you and your business, and you can actually put that information into like a private ChatGPT for you personally or for your company or for a certain amount of people that you decide. You can actually put that information in there, and then you can use these LLMs, like the power of the LLMs, to actually look into your data, even if it's like hundreds or thousands of pages long of all this information. I can actually go through all that information. But the reason you use RAG is that it can actually give you really accurate answers about your personal situation, your business situation, and all that. So a simple example of this is RAG. Basically, if you're asked an answer, instead of you just like kind of guessing based on what you heard, you actually go to a library or go to the bookshop, pick out an atlas, find out, okay, what is the capital of France, as we discussed before. Okay, I can see it's Paris. Okay, then you bring that information back to whoever the person is that asked the question. That's basically how RAG works. Works slightly different than the overall LLM model as we discussed before. So without RAG, AI basically guesses or makes things up, so hallucinates basically, or there's a much higher chance of that, especially if the information that you need from it is actually doesn't know it or it's private to you. So that's why you need RAG if you're doing these kind of things. So with RAG, AI looks at the real documents maybe that you gave it, whether it's your own stuff or whether it's a textbook or whatever it is. They look at these things, so the answers are much more accurate. So much more better, more accurate answers. So now we're going to kind of discuss more the underlying things of how RAG works and the underlying like technical details, but as simplified as possible, how all this works, and like talking about tokens, credits, like vectors, and then just the general overview. So you have a nice overview of AI, how it works, and how it can actually help you, your life, your business, etc. So let's get started on that. Okay, so what are tokens and why do they matter? So tokens are extremely important to understand, at least a simplistic view, when you're dealing with generative AI. So a token is basically things like a word, like a punctuation, like a period or a full stop. Long words could be maybe broken into 2 tokens, and there's other stuff like emojis or stuff like that could be like 1 token. So here's an example. So this is like playing with my dog. That's like four words, as you can see. But this is actually 6 tokens, or it should be 6 tokens. Playing could be broken into 2 different tokens. With my dog, so that'll be 1 token each. And then the period or full stop will be another token at the end. So that's how tokens are usually broken up. Now, why does this matter, and how does it actually help? So basically, by AIs and generative AIs breaking things into tokens, it actually reads the information faster, reads the prompt or like the knowledge base you're giving it, reads it faster, it understands it better, so there's much less chance of it guessing or hallucinating, like giving you the wrong answer. Like, it's much better at that, and it actually responds faster because it doesn't have as much information to go through and everything. And of course, it costs less. Now, costing less is particularly important if you're building AI agent type of stuff for like a business application and so on. So particularly around stuff like support agents. So if your support agent is dealing with thousands of conversations or millions even of conversations, if your cost for each of those conversations is particularly high, it's not very efficient, especially at that scale of millions of conversations. So you want to be having you want to be using a model, because each of these models, depending on how good the model is, usually the better the model is, the more it actually costs. Each token actually costs more, and the worse a model is, or maybe sometimes the older a model is, the cheaper it is. So you want to be using a model here that's good enough to have the conversation, but it's not too good that you're basically not getting the added extra benefit. You might be paying the extra cost for the better model, but you're not getting any extra benefit. And obviously, when you're dealing with thousands or maybe even millions of conversations, these costs really add up. But if you're only dealing with a small number of conversations, like if you're only using a small number of tokens per conversation, it might only be a few cents or whatever. But as you can see, that costs a lot more if you're dealing with millions of conversations. So particularly important, like with business or AI agent stuff, for the costs. So prompt engineering and why that's important, especially like when you see all this. So this is the reason I will go into more prompt engineering in future videos, but the main reason prompt engineering is important, especially for business applications and all that, where this maybe prompt is being queried or asked multiple different times. So if you give the prompt the right context and like you really like keep the prompt as concise as possible while asking the right stuff, this is the stuff it allows you to do. It allows the AI to read that prompt and also the knowledge base much faster, gives it a better understanding, less hallucinations, all that, responds faster, and costs less when you're building these applications. So that's another reason why prompt engineering is super important to actually understand this. And I think it'll be important like well into the future, because even if we don't necessarily have to give like in the future, maybe prompt engineering will actually get easier. But I think being able to prompt engineering and having that clarity in your mind to figure out the right prompt, even if in the future we're actually don't even have to type in our information or even talk. Maybe we'll just use brain implants to actually do our like prompt engineering. But anyway, I'm going ahead of myself. So yeah, that's why tokens matter. And chunking, we're going to go into a bit more about chunking. So basically, chunking is when the AI actually chunks down all the information you give it. The AI chunks that down into a certain amount of tokens. Now, a good average amount is oftentimes 500 tokens, but it depends. So it depends on the meaning, like maybe it depends on how the AI breaks that down. So maybe it'll break it down in the context, you don't want an AI always to be like, it's 500 tokens, and then it breaks a paragraph in half while it cuts out the meaning. So that'll end up having like worse answers for you with AI. So that's why it chunks down to maybe 500 tokens or maybe 800, 700. It usually depends on the size of the paragraph or the meaning of each paragraph. So depending on what way you actually chunk it down or what way you tell AI to chunk it down, it'll decide how many tokens to use per chunk. And that also, of course, does all this stuff as well. Okay, so continuing on from tokens, we're going to talk about chunking. And what is chunking? Well, basically, it's like an AI model breaking the knowledge or the prompts you're giving it. It's breaking that down into smaller chunks that the AI can actually handle. So basically, the chunks are a collection of tokens. It varies in numbers depending on what system that the generative AI is using to break it down or to chunk it, or what system you've told that AI to use. So there's different methods, but three of the more common methods are fixed size. So that that AI is breaking down that knowledge or that prompt into 500 tokens or whatever number you say, but say a common one might be 500 tokens per chunk. Now the thing with that is it's simple, it breaks it down simply, fast, and everything else, but it can break up the meaning of the word or the paragraph. So if a paragraph is longer than 500 tokens, and then the meaning is longer, but it can break it up in the middle. So it kind of like, it messes it up. So therefore it may give you worse answers after the fact. Sentence or paragraph. So this preserves the meaning a bit more, but it can give an uneven size for your tokens. So why that matters, why the uneven size matters is some tokens could be 800 tokens, some could be 50 tokens or whatever, but if like the AIs like tokens that are like somewhat similar, they're not like far off. So if one's 50 and one's like 500 tokens, then that's too much of a difference that the AI doesn't really like that. So you'd want to have it more like one could be 400 tokens or one could be 600. That's like an okay one. And then obviously the closer you have to, the more even you have, the better, while still preserving the meaning length of the sentence. So another one is semantic chunking. So this is probably the most highly relevant one, but the problem is it's a bit more complex. So oftentimes if you're doing your own chunking, you need to be more technical, or you need to have like a more technical developer to actually use these like more technical softwares to break it down. But that's a good way. It's kind of gives you the most relevant, especially if you're building a good system. But I can say that these are probably the two main ones: fixed size or semantic chunky. These are probably the more common ones. So that's a bit about chunky. Now we're going to talk a little bit about credits, and just basically about credits, and then maybe we'll go into a little bit about vectors. What are AI credits? So if you've ever looked at AI software that you want to use, you might have noticed you're paying a monthly fee for them, but you also might notice like you get a certain amount of monthly credits per month or whatever the way they're charging it. But if you go beyond that certain limit, you actually have to pay extra to actually use more credits. Well, that's because a lot of those softwares are actually built on top, or at least using these AI models like ChatGPT or Claude. They're using them, so they actually have to pay to use their data centers and computers to do the tasks and to run their tasks. So if they don't charge you extra credits if you go beyond a certain limit, then it's costing these softwares more money. So that's the reason they need to charge those extra credits if you go beyond a certain limit. So basically these AI credits are like a currency to pay for models like Claude, ChatGPT, all those ones. You get maybe Google Gemini. And usually you're charged per 1,000 tokens you actually use. And this kind of includes every prompt and every response. So if you type a prompt into the AI and then you get a response back, well, that full thing would be all the tokens in that full thing would actually be charged. And the same with like if you put in a prompt and you get an image back, well, that image and the prompt are going to cost tokens, but of course the image is going to cost a bit more because it's using more compute, and obviously even more so if you're creating video prompts. So you can kind of see how that works. And so AI credits, basically, the reason that we actually have to pay for AI credits is it reflects the computational effort required. So this kind of includes like energy, which is like electricity, the hardware usage, so like the GPUs in these massive data centers, and the time you're actually using those GPUs. So that time could be like milliseconds or seconds or minutes or longer, depending on how complex that task is. Probably a lot of the tasks aren't so complex, but like there's obviously so much tasks going on at the same time all over the world. So a lot of this can be summed up as compute. So you might have heard that word, how much compute does it take? This is kind of like summarizes all this kind of stuff here. So the more tokens you're using in like your prompt, your response, maybe if you're getting images, the more tokens you're using, obviously the higher cost, because simply put, it's using more compute, it's using more of this stuff. The faster it happens, the higher the cost, and that's because you're getting priority usage. You're getting, obviously, jumping ahead of the queue of other people, and less latency. So latency is like you're taking action and a response comes back a lot quicker, a lot faster than other people's. So the bigger the model, usually, I suppose it's not always the case, but higher, like it's basically usually costs higher, because the bigger the models, the more memory to use, the more compute is used and needed for them, and then of course the more electricity to power that compute. So yeah, that's a general overview of credits. So next we're going to go into vectors, and then yeah, we'll summarize all of it after that. So yeah. Okay, so what are AI vectors, and how does AI or large language models understand the meaning behind this language? So basically, to keep this as simple as possible, AI turns this language, this human language like English or Spanish or whatever, it turns that into numbers that can actually understand, because AI is much better at understanding numbers and maths rather than like human languages. So this process is called like AI vectors. I'm going to give you some simple examples of this. So the sentence, I love chocolate. So AI doesn't actually store this sentence like this. It actually turns this into numbers and then puts those numbers into a searchable database. So for this particular case, these numbers would be 0.23, then minus 0.14, and then 0.19. And that will go on continuing for about 1,536 different numbers. And that's because in this particular model that was used to turn this language into vectors, there's a particular model that was used, and this model has a total of 1,536 numbers for each meaning. So that's why in that case. But obviously there's different models you can use to do this, but I don't want to go into that in this video at the moment. I just want to continue on. So there's another sentence here, chocolate is my favorite. So as you can see, that sentence is pretty similar to that sentence. So the numbers for this are 0.25, minus 0.12, and 0.88, and so on. So as you can see though, these numbers are pretty similar, like 0.25 and 0.23, they're pretty similar. They're not far from each other, and then so on with the rest of them. So that's how AI is working. It's turning these numbers into similar numbers based on the meaning behind the actual human language. But as you can see, another example, I hate chocolate. Obviously this is the opposite basically of this one. So these numbers are minus 0.12 0.34, and minus 0.37. So as you can see, that's very different. Like 0.19 is very different. It's almost the opposite of 0.25, and so on with each of the other numbers. So as you can see, the AI is working out that this actually, in fact, means something very different. It's similar context in that it's chocolate, but it's a very different meaning here than this one. So that's the simplistic view of what AI is doing to understand this language, how it's turning it into numbers, and that general whole process. So I hope that was helpful. See you guys in the next video. Okay, so I just wanted to like summarize everything and just kind of show you a simple process for how an AI chatbot is created, or like an example of a private GPT that is created. Now, if you're creating a private GPT with OpenAI, a lot of that is kind of done for you, so you don't have to worry about it. But I just kind of wanted to give you an overview, and then if you're doing like a business application, this is like the general, more simplistic thing of what is happening to create like a knowledge chatbot or like a customer service chatbot. So basically, first of all, we need some kind of a knowledge. We need like the knowledge of your overall business, like that's PDFs, books, whatever kind of knowledge that you have. We need to gather up all that knowledge. And like books, PDFs, as I said, we need to chunk that knowledge. So as I said, chunking is breaking those tokens into manageable chunks. So a happy medium is kind of say 400 to 800 tokens. So you chunk all that document up of maybe it's like a 200-page document, chunked up all that into like 400 to 800 tokens. And then each of them, we embed them. So each chunk then turns into a vector. So as I discussed before, a vector is basically the AI turning the meaning of these chunks into searchable numbers and math. So it actually helps the AI understand meaning better and search things much quicker. So an example of one of these embedded models is OpenAI's text embedding 3 small. So that's just a simple model on the back end. It's not the same as the front end models that OpenAI have. It's a back end model that actually just is used to turn this information, like these chunks, into vectors. But we want to make sure that the model we're using is consistent across all the knowledge base, because if it's different, then it's not going to work. You need to use the same one. But then the next thing was we store these vectors in a searchable vector database. So more complex ones, something like a pine cone. Other ones, like a simpler, lower code one, is Relevance AI. Of course, there's more. And then like private GPTs, like OpenAI, if it's more simple one, they'll handle most of that for you. So then next thing is we need an AI interface. So this is like where we ask a user, or we ask the questions to the AI. So obviously a lot of people probably have seen OpenAI's user interface, the simple thing where you ask questions to it and then get a response. Other things you could actually use for interfaces sometimes, if you're building your own, you can even use like WhatsApp or Slack or different other interfaces as well, or obviously you can build your own too. So what exactly happens when you ask that ChatGPT or whatever the interface, the AI question? So you ask that question, then that question itself is also turned into a vector. Similar to the knowledge base, they're also turned into a vector, which is like maths. And then that vector is then searched within the knowledge base of all the other vectors it's already seen. So it figures all that out, searches all that, and then gives you the final answer when it puts it all together. So that's just a simple overview of how these things happen, how they operate. I often find this kind of stuff kind of useful just to know the underlying thing in a simplistic way. So yeah, if you like this video and want to learn a bit more about AI or even other like business related stuff, definitely subscribe below, and see you in the next video.